Hey guys, it's Sukrit from STEM Coder. As you may recall, in the last video we talked about what is calculus. And there were two major branches of calculus, integral calculus and differential calculus. Well, differential calculus involves the taking of derivatives, and so today we're going to learn what is a derivative. Simply put, the derivative is the rate of change of a function. Remember that, rate of change. Calculus is the study of continuous change, so it makes sense that the derivative is the rate of change of a function. If you graph a function on a Cartesian graph, its derivative is actually equivalent to the slope. Pretty convenient. So let's look at this function. F of x is equal to 0.5x. As my x changes by 1, how much does my y change by? It changes by 0.5, right? So if I go in my x direction by 1, my y changes by 0.5. The slope of this function is 0.5. That's the rate of change of this function. And so the derivative of this function is 0.5. Let's look at a more complicated example. This function f of x is equal to x squared. Well, we can clearly see that the slope isn't exactly a constant, right? Because the function is steeper here than it is here. So let's actually measure the slope. We can take the slope of a function using a tangent line. So over here, let's draw a tangent line to this point where x is equal to 1. So at 1 comma 1, well, the slope of this tangent line is actually equal to 2. So slope is equal to 2. Well, let's draw a tangent line at x is equal to 2. So at the point 2 comma 4, tangent line looks something like this. It's definitely steeper, right? Well, the slope of this tangent line is equal to 4. So when x is equal to 1, the slope is equal to 2. When x is equal to 2, the slope is equal to 4. Do you see a pattern over here? The slope is equal to 2 times x. And on a Cartesian graph, the slope is the derivative. So the derivative is 2x. So when you have the function y is equal to x squared, the slope of that function at a given x is equal to 2x. Pretty cool, isn't that? There are many practical applications to derivatives, obviously. One is finding the maximum profit. So let's say I graph the profit a company makes versus how many different products it makes. And you can see that the profit increases as it makes more of that product and then decreases after a while. Well, in order to find the maximum profit, I just take the derivative of this function, and where the derivative is equal to 0, where the slope is equal to 0, well, that's going to be my maximum profit, because you can see the tangent line over here, slope is equal to 0. That's a pretty cool application of derivative. Another example is car acceleration. As you may recall, acceleration is the rate of change of velocity, and engine power is another application of derivative.